Greetings. This is David and Corey here for 9CI Designstream 004. And on this design stream, we're actually going to talk about a DC off-the-grid house. So this is a house that's going to be off-grid or very narrowly connected to the grid and going to run on DC power. And it's going to use some renewables. There's going to be some batteries. Corey can tell us all about it. The focus of this episode is the topology, how all of the electronics are connected for this house. We're going to do something a little bit unique on this, and there's some cool reasons for that. So, Corey, tell us about the house.
Yeah, so a friend of mine here in Alaska has a cabin that is currently totally off the grid, and the nearest power line is about 500 feet away. And so I've been looking at how to hook this, how to get some power out there. And it turns out it's really quite expensive. The pole drop was it was the cost of the pole, the meter, the hookup, a line across. It was pretty expensive to get the pole, but now the cost is several hundred feet of high or low gauge cable that can supply lots of current to the house for all of its power demands. And
you have a diagram of that, right?
Yeah. So normally this would be a 500 feet of 6 gauge copper cable coming from your pole. So you have your split transformer here, split phase power coming off your transformer at your pole, 500 feet, and go straight to your house, and you'd have outlets. This is very expensive. I think it worked out to, with just this wire, was like $700 or $800. And I found that for that same cost, you can get most of the way to a solar system. And the way that works is you have 500 feet of high gauge or very rather small copper or aluminum cable that supplies just a couple amps all the time. So one of the things, like when you flip the lights on in your house, you are consuming energy that is generated at that very instant. So the minute that the light, or the moment that the light hits your eyes, like basically that power has been generated at the power station at that same moment. So you have to size your cables for the maximum demand that you'll ever use. And this system is constantly charging a couple 8D deep cycle batteries, which we'll probably get into battery selection in a later video, because that's a pretty big topic on its own. And so I have it sized so that you're pulling about 4 amps of 240 volts all the time to keep your batteries charged, and then you're able to draw a lot of power very quickly off your batteries. And most of your high current loads are not very long duration, so you need a lot of power really quickly to run, load laundry or cook some food or anything like that. And this system is able to provide that. It's kind of like a water tank that's fed by a small line and a small pump.
So you can drop, basically, instead of sizing that 500-foot run for full load and it costing $700, you could use, as long as your wire is rated for 110 volts or whatever your drop is, 240. You could use really small wire, even scrap wire or something a lot cheaper, like Romex or something, and use that money instead to build that battery box.
Right. And we'll look at the total cost breakdown, but the numbers I was coming up with for wire that I can get locally was like, it went from like $750 or $800 to $150. So it was big savings on the copper. And that made buying batteries and a battery charger and all this stuff it ended up coming out at about the same price with a bunch of extra stuff. And like I said, you can always add solar panels to this system later on, so that you could eventually cut this cable and save $30 a month for your meter fee.
Sure, right. And the other benefit is, for the same price as being hooked directly up to the grid, you actually have local energy storage in that battery box. So if the grid goes down, you got some energy right there.
Yep. And this cabin's in a remote area, so it's not super unlikely that you would have outages from time to time, where a storm comes and knocks out a line, or squirrels get in a transformer or something like that.
Sure. Cool.
Yeah. So that's the basic structure of that. And so there's the batteries themselves, the chargers, and then the inverters. One of the things that came up while I was working on this was that this works kind of at different scales. So this idea of trying to reduce the cost of or the amount of conductor that you need, or busing that you need between your energy source, in this case your batteries, and your energy load, which would be like your fridge. And you want to keep that. You either have to raise your voltage, which means more batteries, or you have to shorten your distance. And as you shorten your distance, you run into this issue where you have a bunch of stuff clustered around your batteries. So
this is, again, if you go back to that last diagram just for a second before we move on, to the left of your battery box, you have this 12-volt DC run and this 110-volt run. These would be, the inverter makes 110 volts AC, for powering regular stuff. The 12-volt DC is just straight off your batteries, basically. You run into that copper problem. So we solved the expensive copper from the pole to the battery box. And now we're running into that same problem between the battery box and the cabin. And so now we're trying to chase that cost out.
Right. Yeah. So as your house gets bigger, and as your runs between your battery box and your battery box would be right next to your cabin. There's reasons to have your batteries inside, reasons to have them outside. One is Deep Cycle's vent hydrogen, so you want to keep that away from flame sources. You got to keep this warm, and then if you use lithium batteries, they can catch fire, so it's good to keep that away from your actual house where you're at. So I just have this drawn as a battery box that's outside of the cabin, but as soon as you do that, you run into line loss, and even if it's in your house, you have line loss as you have to run loads to different parts of your house for say you have a washing machine or a dryer on the other side of your house. Now you got to run really expensive double aught cable from your batteries to your high current load. So that's this picture, and this is a distributed I said power. It's distributed storage system. So you would have multiple. Again, it's kind of a copy of the long small cable that runs from the pole. This is a power source, and this is a power source, and you're just connecting them with a small wire and some electronics. So here you would have different battery banks throughout your house, again, inside or outside. And then you would have little battery menders that would, as one, they're kind of independent systems, but as one battery is drawn down by, say, a load of laundry, the other packs in the system would, over the next couple hours, they would charge that battery back up. And this also lets you cycle through your batteries, and you don't have the huge upfront cost of having to buy all the batteries for all of your loads at once. You can kind of add one year and add another couple batteries the next year. And it also means that when your batteries need replacing, you don't have a huge expense. You can cycle through the replacement as well with a couple batteries every year.
Yeah, exactly. So the idea is you have distributed energy at the load. So you have a battery at each major load, and that battery can run that load, and then it's connected to a common tie where all of the distributed batteries can sort of recharge each other and recharge as a group over time, like you said, an hour or two. And so then you're able to basically run this whole system at low voltage and low current, so you don't have anything lethal or scary in your wall, and you haven't spent really any money on copper. And another benefit is you can run the whole thing at DC. You can run the whole thing with direct current. You don't need inverted AC, and so you're not going to have any problems with dirty electricity, in particular from noisy solar inverters. And so as far as electromagnetic fields go, it's going to be a really quiet house.
Yeah, and that was one of the considerations for this this project, was that my friend wanted a very quiet RF space, and was very excited about the DC only side of this. And because of because of solar getting cheaper, there's more and more appliances that are already set up to work on DC, and they're kind of expensive, but like you can get DC fridges and DC freezers. Pumps are already DC, so that's great. And a lot of appliances, they step down the voltage and then they rectify it to DC. So if you're using either high voltage DC, like 110 DC, you don't need to you don't need to do anything. A lot of things you can just plug into the wall or into that DC, and it works just fine.
Yeah, like most power adapters for consumer electronics, they work if you plug them into an AC wall socket or a DC wall socket. They don't care.
Yeah, and one of the things that came up when I was doing this, and again, batteries is a big topic. We'll do that on a different one, but these are deep cycle lead acid, and they work particularly well for this application because they function basically as chemical capacitors. They lead acids really like to be charged up all the time. They don't like to be cycled a whole bunch, but they're industrially used for battery backup systems, which is basically what this is. This is like a grid tie backup, and the backup being that if you drew too much power at any time, your voltage would sag. So these are just providing extra current for your system.
Yeah, very cool.
So I have a little bit of stuff on chargers. This is mostly coming from the solar world. I was looking at a Meanwell and found that reading people's reviews of it, that it had issues, which would be specific to, or would be an issue in this scenario, that some chargers have a hard time providing current to charge the batteries at the same time that they provide current for loads on the system. So if you turn a load on, you have some lights going, that can kind of fool a charger into not knowing what the state of the batteries are. And most chargers, they have some different charge profiles, so they'll run the batteries through different they'll step them through different voltage and current configurations for battery health and battery management. And not all some chargers are only chargers, and they can't be used as this kind of hybrid charger power supply. And I found that IOTA Engineering has some good AC to DC battery chargers that work well for this application, and they can be stacked in series or parallel or both. And they also have this cool feature where instead of different software versions, they have physical hardware modules that have the software loaded on them, and you just plug those modules into your battery chargers, which is kind of they're like physical cards that plug in.
It's like Nintendo cartridges.
Yes, yeah, I thought that was really neat. So.
Right, that's cool. That's cool. So the next step on this project, the next thing to talk about, which we'll get into on our next conversation about this, is your choice of batteries. And you found that lead acid was the way to go, which will surprise some people. I was in the lithium-ion battery space a few years ago and was part of a 12-volt, 24-volt, 48-volt lead acid replacement project. And the further we got into the project, the more we discovered that lead acid's actually not that bad. It's actually pretty cool. So that'll be a fun episode to talk about your findings on that. And that'll be coming up in the next couple of days.
Yeah, just a few highlights of that is it's like 98 to 99% recycled materials. It's basically a closed loop manufacturing process. Which is why core charges is such a big deal on lead acid. It's like it can be a third of the cost because you're basically just paying to have your batteries refreshed. So,
yeah, batteries as a service.
Yep, they're really neat. And I totally overlooked them before this. I was pretty gung ho on the lithium stuff. So, and I think there would be some interesting stuff to do or to look into, especially for solar, using lithium or some other chemistry, some high current, high cycle life chemistry to buffer your energy as it comes in from your solar system, and then store that long term in lead acid. So kind of get best of both worlds.
Yeah, that will be fun to talk about.
Yeah, so more to come on the DC trickle charge distributed powerhouse.
Yeah, that'll be cool. And we're actually going to have to build some widgets to do this too. Like potentially we're going to have to make some little power converters and stuff, which would be a lot of fun.
Yep. And there's it's kind of like a big battery management system, which you've worked on several times. And one thing I haven't really seen, I've seen boards that do it, but I haven't seen a whole system that does it. But if you have a couple 8D batteries, like that's a fairly expensive setup, and it would be nice to have a little board that just sticks on and lives on that battery and can, provide alerts or provide cycle life, like count the number of cycles and that kind of stuff. So there's that. I have that's it for that. I have a couple things. I have a tool review I'll be doing. This is a Bosch screwdriver, which I was very excited about until I got it, and I'll get into that on the tool review.
Is that a single lithium battery one?
Yeah, and it's got the push.
Oh yeah,
there's a little sensor in there.
Oh yeah, that one. Yeah. Okay.
Cool. And it also it's got a torque setting, and it's all electronic. It's not a clutch mechanism. But the big downside is no use while charging.
Snap.
Which I looked and I couldn't find anybody to answer that question online, so I had to buy it. The other one I have is this is a dual output reversible DC motor controller, and I have a DC motor with a gearbox. Well, I have two of them, and so there'll be more on that later. So.
Interesting. That's very cool. Yeah, we will. So, and we'll actually be building some of this stuff. I may be. You got into that blockhouse problem of where the heck do you put your batteries because you don't want them in your house. That is a problem I want to solve at my house in Alaska as well,
And
which is where I
you
will
had
be over the summer.
you had a cool solution for that, which I won't
Yes,
spoil here. But
we may actually implement that solution. I'm going to talk to my dad about doing that. Um, but yeah, there'll be a lot more to come in this series. That's for sure.
yes.
Cool. Well, let's get into batteries. Let's get into batteries next, maybe in a day or two, maybe tomorrow or Monday, something like that, so people can watch for that.
Oh yeah, and one more. Oh, if you can put my screen share on.
Oh, yep. Boom.
Yeah.
Oh yeah.
Got a battery cart.
Are those your batteries? You already got them?
Yes. Those are sitting in my driveway right now.
Excellent. Cool.
We have a mutual friend in Fairbanks that I asked who has needs for industrial batteries for equipment and stuff. And I had run my my cost spreadsheet on batteries, which briefly looks like this, because I spent a lot of time looking for batteries. And I should have just texted him first, because I found a battery supplier in town. I was like, whoa, this is amazingly cheap. And I was like, hey, where do you get your batteries? And he was like, oh, get them from this place. I was like, nice. Well, cool. I hope you don't need any, because I'm buying them out right now. So.
The entire local supply.
Yes. Yeah. So
very cool.
All right.
We'll jump into batteries next time. Thank you for joining us on Designstream 004. We'll see you on episode 5.
See you, everyone.